Hello students, this video is about position time graphs. So here we are going to plot different position time graphs such that time will act as independent variable and position will act as dependent variable. That means position will change according to time. So position depends on time and it will change as per the time. Means जैसे जैसे time change होगा accordingly position will change. So time act as independent variable and position will act as dependent variable. So when we plot the graphs, we take time on x axis while position on y axis, as we take independent variable on x and dependent variable on y. Now there are three possible cases. That first, the case of stationary object. Second, for an object which is in uniform motion. And third is for an object which is showing a uniformly accelerated motion. So we are going to discuss three different graphs for three different type of situations. First is for stationary object, second is for uniform motion, an object when in uniform motion, and the third is when an object is a uniform accelerated motion. So stationary object means the object is not moving, its velocity is 0. Uniform motion means the object is moving with a certain velocity, it has velocity, but its velocity is constant and acceleration is equal to 0. That means there is uniform motion. And uniformly accelerated motion means the object has some velocity which is changing. Okay, the velocity is varying, but the velocity varies such that the acceleration of the object remains constant. So this is the situation. Means if an object has no velocity, if an object has constant velocity and no acceleration, and if an object has varying velocity but constant acceleration, that means its acceleration is constant, its motion is uniformly accelerated. While in this case it is in uniform motion, means its velocity is constant. So now let's talk about the first one. First is for an object that is stationary. So if the object is stationary, it has 0 velocity, that means its position is not changing. Now we are going to make graph between position and time for a stationary object. Since the object is stationary, so there is no velocity, and since there is no velocity, the object is stationary, that means that object is not moving, it is fixed on a certain position. Suppose initially the position of the object is here at x naught. The position of the object is at x naught. Now we are taking time, the independent variable on x axis, and position, the dependent variable on y axis. Okay, so initially at origin or with the start in time, we have the position of the particle at x naught, and the object or the particle is stationary, it is not moving. So after time t, it will again be at the point t naught. After more 10 minutes, 15 minutes, it is still on the same position. Again after 10 minutes, it is still on the same position. So throughout the time period, the position of the object remains same. That means we are going to have a straight line that is parallel to x axis in this case. So if we have a stationary object, the object remains at a constant distance x naught from origin to all the times throughout the observation. Then the position time graph for such object is a straight line parallel to time axis. Okay, so we write it here. The graph we get is a straight line and parallel to time axis. So this is the position time graph, or xt graph. We also call it as xt. X is position, t is time. Xt graph for stationary object. Now let's see the second one. In second case, the object is moving with some uniform or constant velocity. It has no acceleration, but it has some velocity which is constant and have some value v. So in that case, when we plot a graph for such object, let's see how it will be. So we assume that at origin, at the starting point, the position of the object is x naught. Now the object is showing a uniform motion. That means the object will cover equal distances in equal intervals of time. If an object is showing uniform motion, it means it will cover equal distances in equal intervals of time. So in that case, the graph will start from x naught, because this is the initial position of the object. But after this point, it moves such that it cover equal distances in equal intervals of time. So it shows a straight line path which is inclined to the time axis. For this situation, the graph will have a straight line path which is inclined to the time axis. So it will be like this. Now this is the initial position of the object, and after this position the object will travel such that it cover equal distances in equal intervals of time. So it will give us a straight line that is inclined to the time axis. This is the time axis, and here y axis is the position axis. Now the slope of this graph will give us the velocity of the object. So we can calculate it also. We are assuming that at a certain point, at the time t1, the position of the object is x1, and again at some time t2, the position of the object is x2. So we are considering that at t is equal to t1, the object has position x1, and at t is equal to t2, it has position x2. This forms a triangle PQR, where the angle QPR shows the angle of inclination of this line with time axis. It will be the same angle. If you produce it backwards, the angle theta will be same. So theta is the angle of inclination of this straight line from time axis. Now to find slope of this graph AB, what we have to do, we have to find tan theta, tangent of the angle or the inclination. So we can find tan theta by the triangle PQR, as we know that tangent of angle is equal to perpendicular upon base. So for this, tan theta is equal to QR upon PR, where QR can be given as, QR is this distance, that means x2 minus x1 on the graph, and PR is this, that means t2 minus t1 on the graph. Here x2 minus x1 shows a change in position, that means displacement, and t2 minus t1 shows the time taken. And we know that displacement upon time gives us velocity. So this shows that for this graph, for this position time graph, tan theta, or the slope of the graph, is equal to velocity. Hence what we conclude is, for a position time graph, the slope represents the velocity of the object. Okay, so the slope of this graph represents the velocity of the object with which that object is moving uniformly. Now after this we will move to the third case. Now the third case is for a uniformly accelerated motion, means this time the velocity of the object is changing. The motion of that object is such that it has some acceleration, and the acceleration is constant. in such situation, the object will follow second equation of motion, that is s is equal to ut plus half at square, because it has some initial velocity and is moving with some constant acceleration throughout the motion, and s is the displacement. That means we can write it as x minus x naught, where x naught is the initial position and x is the final position at some time t. So x minus x naught is equal to ut plus half at square. This is the equation that the object follow, or the trajectory of that object is given by this equation. We can rearrange it to get x is equal to x naught plus ut plus half at square. Now this shows that the position or the distance x is directly proportional to t square. Means x is a quadratic function of t. We have to plot a graph between x and t, where t is independent variable and x varies according to t. That means x is dependent on t, and the dependency relation is x proportional to t square. That means x depends on t in quadratic form. So in that case, the graph we will get will be parabolic in nature. X proportional to t square represent the position time graph for uniformly accelerated motion is a parabola, and we can show it by a curve, like as I'm going to show in the diagram. So this is how the graph will appear in a parabolic shape. X naught is the initial position when body starts moving, and x is its position at some time t. Now we know that the slope of position time graph show velocity, but here in this case velocity is changing continuously. So if I draw or plot a tangent at a particular point, then this slope of this tangent at this point will give the instantaneous velocity for this point. Similarly, suppose I plot a tangent at some point a, then the slope of this tangent will give the instantaneous velocity of the object at point a. Okay, so we are going to find this slope of tangent, means instantaneous velocity kitna hoga for that object, that we are going to find. How can we find that? So for this we are going to have slope of position time graph. Now position time graph ko I can write xt graph. It is the same thing. Slope of position time graph. In this case, I am not taking a right angle triangle. Instead of that, I am considering small changes in vertical and horizontal coordinate. So if I take a small change in vertical coordinate and horizontal coordinate, I get a triangle like this, where this will show a small change in vertical coordinate and this line will show a small change in horizontal coordinate, and this is the tangent at some point on the graph. Let this point be P. Okay, so this is the tangent at point P, where x dx will show the change in vertical coordinate and dt will show the change in horizontal coordinate. Then in that case, slope of this tangent can be given as a small change in vertical coordinate upon a small change in horizontal coordinate. So the formula will be slope of xt graph is equal to dx over dt, and we know that dx over dt is the velocity at point P, or we can say it as instantaneous velocity, means जिस point पे हमने tangent लिया था at that point. So instantaneous velocity. So the slope of a position time graph for uniformly accelerated motion gave us its instantaneous velocity. Okay, so this is the third case or the situation that is possible. So we can have a stationary object, we can have an object in uniform motion, or we can have an object in uniformly accelerated motion. These are the three possibilities for position time graph. That's it for the video. Thanks for watching.